Hey there, in this video we're going to cover laws of logarithms, but before I do that I wanted to just do a really quick review of what we know so far about logarithms. And one of the most important things is the definition of the logarithm, because this will come up quite a bit, especially when we get into solving equations and anything with logarithms. It's really important to know the definition. And so the definition of a logarithm is if you have the log base a of x equal to y, this can be rewritten as an exponential. The exponential is a to the y equals x. And usually you'll see a double arrow because it means it can go both ways. So you can take a logarithm and write it as an exponential, or you can take an exponential and write it back as a logarithm. So some of the things to know are the base. So we are familiar with exponentials, and a is the base of the exponential. Logarithms are the inverses of exponentials, so the base will remain the same. So the base of the exponential is the base of the logarithm, and then the y is the exponent. Okay, so this is the exponent. So when we have an exponential, so in the logarithm definition, our exponent is what it equals. So oftentimes you'll hear people say logs are exponents, and that's because the answer to a logarithm is an exponent, right? For example, if I ask you to evaluate log base 9 of 81, this is really asking you what exponent do you put on 9 to get 81, right? So 9 to the what power gives you 81. So what exponent? So you're looking for the exponent. And in this case it's 2. 9 squared is equal to 81. So log base 9 of 81 is 2. So the answer to a logarithm is an exponent. And then the result. So on an exponential, what it's equal to, that's the result. And so for a logarithm, right, this is the result of an exponential. The answer. So this is our definition of logarithms. And so with the examples, right, like in this one, what exponent do you put on 9 to get 81? And so we could do other quick examples. Like if I said log base 2 of the cube root of 2, for example, right? This is what exponent do you put on 2 to get the cube root of 2? Well, that would be 1/3, because 2 to the 1/3 is equal to the cube root of 2. Thinking about a fractional exponent becomes a radical. So I'm getting a little bit more complicated, right? So if I had something like log base 4 of, what about if I leave it as the cube root of 2? Now, what exponent do I put on 4 to get the cube root of 2? So this may not be as obvious as these, where we can do them in our heads, right? Like in part A, what exponent do I put on 9 to get 81? And like, oh, 9 squared is 81, so the exponent must be 2. Log base 2 of cube root of 2, what exponent do I put on 2 to get 2 to the 1/3? Well, my exponent has to be 1/3. This one's a little bit more complicated. At least I can't do it just by looking at it like I do log base 9 of 81. So whenever you don't know, you can call it y and use the definition of the logarithm, right? So I have it equal to y, and now I can use the definition to write it as an exponential. So oftentimes with logarithms, we have to write them back as exponentials because exponentials are easier to work with. So this will become then 4, the base, to the y is the exponent, equals to the cube root of 2. And we already know that the cube root of 2 is 2 to the 1/3 from the previous problem. And now we look at this and we're like, okay, so I have 4 to the y equals 2 to the 1/3. If it was 2 to the y equals 2 to the 1/3, that would be nice because the bases are the same. So the trick with this is to get the bases to be the same. So my base of the exponential here is 2 to the 1/3. So I want to be able to write 4 with the base of 2. So can I write 4 with the base of 2? Yeah. 4 is 2 squared. And now I use my properties of exponents. Power to a power, we multiply. So this is 2 to the 2y equals 2 to the 1/3. Now that the bases are the same, if I have 2 to the something equals 2 to the something else, the exponents have to be the same since the bases are the same. So I can say the exponents, so 2y equals 1/3. And now I can solve for y. Multiply both sides by 1/2 to get rid of this 2 here. So y equals 1/2 times 1/3, which is 1/6. Right, so what I did here is multiply both sides by 1/2, or sometimes you can think of it as divide both sides by 2. And so my answer is y equals 1/6. So to finish it, the answer to this logarithm then is log base 4 of the cube root of 2 will be 1/6. So what exponent do I put on 4 to get the cube root of 2? 1/6. And that's not something that you might necessarily be able to do in your head, but by using the definition of the log, we can change it to an exponential and solve. So that's one of the reasons that I say knowing the definition of your logarithm is very important. So now here I can say 4 to the 1/6 is equal to 2 to the 1/3. And notice that you can check it. 4 is 2 squared, so I have 2 squared to the 1/6. Does that equal 2 to the 1/3? And now using our power to a power, this is 2 to the 2/6 equals 2 to the 1/3. And yes, that is true. So it checks. So that's using our definition of the log. So some of the properties of logarithms come straight from the definition. And so some of them, I'm going to write just a few before we go into the laws. So before I write the properties, let's do a quick examples. So just to verify. So if I have log base 2 of 2 to the 17, what is that, right? So this logarithm expression is asking you a question. What exponent do we put on 2 to get 2 to the 17? And it's like, oh, that must be 17. What about log base 11 of 1? What is that equal to? So again, think of it as a question. What exponent do we put on 11 to get 1? So 11 to the what power gives you 1? So that must be 0. So let's replace the question mark with our 0, right? And this is because, so this is my lazy because 11 to the 0 is 1. So that leaves us with some of the properties. Log base A, regardless of the base of 1, is 0, right? And that's because A to the 0 is 1. Second property, log base A of A, what is that? And again, comes from the definition. What exponent do I put in A to get A? Well, it must be 1. 3, log base A of A to the Y. What exponent do I put in A to get A to the Y? Well, it must be Y. So these are just know what a logarithm is, but we call them properties. And the last one, if I have the reverse of this, if I have A to the log base A of Y, then I'll get Y. Remember, logarithms and exponentials are inverses of each other. So if I have a log base A of an exponential of the same base, I get the exponent. So likewise, in property 4, if I have an exponential of base A to where my exponent's a log of the same base, then I'll just get the inside, the Y. So those are our properties. So now let's go into the laws of logarithms. In the laws of logarithms, remember logs are exponents. And so just to kind of give you an idea, back when we had, so with exponents, if you have a to the x times a to the y, what do? When you multiply the same bases, we add the exponents, right? So I get a to the x plus y. So when you multiply the same bases, you add the exponents. When we divide the same bases, we subtract the exponents, and so on. So the properties of logarithms, because logs are exponents, they come from our properties of exponents. So the first one, the first law is if I have log base A of capital A times capital B. So when I multiply two things and notice I have the same base, then this is going to be the log base A of A plus the log base A of B. So when we multiply the same bases, we add the exponents. 2, when we subtract, so when we divide the same bases, we subtract the exponents. So this would look like A over B is equal to the log base A of capital A minus the log base A of B. Power to a power, we multiply the exponents. So in logarithm form, that becomes, if I have log base A of capital A to the C, to an exponent of C, that means I can put the C to the front. It will be C times the log base A, lowercase a, of A. So those are our three main laws of logarithms. And so just to kind of draw a parallel, I'm going to do it with some exponentials. So I know 2 cubed, what's 2 cubed? That's 8, right? And 2 to the 4th is 16. So watch this. If I have 2 cubed times 2 to the 4, what are we going to get? This is going to be 2 to the, I have the same base. We add the exponent to the 3 plus 4, which is 2 to the 7th, which is 128. So now, if I have a logarithm, what this says is I'm going to start with the 128. So log base 2 of 128, and I'm going to backtrack but in logarithm form. So this is the same thing as saying log base 2 of 8 times 16. Right? 8 times 16 is 128. And so now what this is I have log base 2 of 8 plus log base 2 of 16. Which notice this is my, this exponential. Log base 2 of 8 is equal to 3. So I have 3 plus, what exponent do I put on 2 to get 16? 4. So I get 7. So log base 2 of 128 is 7, which is when you multiply the same bases where you add the exponent. So my exponent was 7. So that is the parallel, right? Logs are the exponent answer. What exponent do you put on 2 to get 128? The exponent that I put on it is 7. And so, but this property comes from when you multiply same bases, you add the exponents. So let's put them in practice. Let's try some examples of using the laws. So our instructions are going to be use properties of logarithms to expand. So use properties of logs to expand. And the first one, let's say, is log base 3 of x cubed y to the 4th over z to the 6th. And so let's go back to the laws. So I have, when I multiply the inside of a logarithm, we expand by writing it as the sum of two logs of the same base. When we divide, we subtract, and so on. So I think I have all three of them. I have a division, I have multiplication here, and I have things raised to a power. So we're going to use all three rules, but how do I know which one to use first? Well, which operation jumps out the most? And the operation that to me jumps out the most is right away the division. So we're going to use the division one first. So this is going to be the log base 3 of the numerator. So I'm going to leave the numerator as it is. And then minus, right, division inside a logarithm changes to subtraction of two logarithms of the same base. Log base 3 of z to the 6th. So now I have, okay, Now I don't have a division, but now I do have a multiplication. So we're going to use the law of multiplying. So this is going to become log base 3 of x cubed. Right? The times inside a logarithm becomes a plus of 2 log expressions. So it's going to be log base 3 of y to the 4th minus log base 3 of z to the 6th. Notice that all the bases are the same. And now I can use the last property of logarithms that says if I have log base a of something to an exponent, I can bring the exponent to the front and multiply by the logarithm. So that's what we're going to do with all these exponents. So we're going to take the exponents and multiply them to the front of that particular logarithm. So this is going to become 3 times the log base 3 of x plus 4 times the log base 3 of y. That was a 4, right? It looks like a 9, but it is a 4. Yes. Minus 6 log base 3 of z. And so this is, now have I completed expanding? So how do you know if you've completed expanding? Well, are there any multiplications, divisions, or exponents? No. So then that's as far as I can go. So let's try another example. What about, maybe we want to expand. So now the natural logarithm of x times the square root of y over 2. So how do we tackle this one? So there is a division, but notice that now this division is within a power and then after a multiplication. So I'm going to do the multiplication first. So that means that this is going to be the natural log of x. My times is going to become a plus, and I get 2 logarithms now, right? So it'll be the natural log of the square root of y over 2. So I'm going to say y over 2 to the 1/2. Converting that radical to a power, so I can use the power property. So then this becomes the natural log of x plus, I can use that property of bringing the exponent and multiplying it to the front of the logarithm. Notice that I multiplied to the front of this logarithm because the power belongs to just the y over 2, not to the x. So I don't bring it all the way to the front here. I just bring it to the front of that logarithm. So it'll be 1/2 times the natural log of y over 2. Am I done? So how do you know if you're done? Do you have any more multiplications, exponents, or divisions? I still have a division here, y divided by 2, so I need to keep going. So we're going to say this is the natural log of x plus 1/2, and I'm going to have to expand this using the quotient law. So this will be, then I'm going to use parentheses, so it's going to be the natural log of y, and because it's division, it's going to be minus the natural log of 2. And now I need to distribute this 1/2. So it'll be ln of x plus 1/2 natural log of y minus 1/2 natural log of 2. Okay, bring the 1/2. Now notice that this is a coefficient, so we have to put it in the front of the logarithm. So don't make the mistake of saying 1/2 times 2 and accidentally canceling off those 2. This 2 is inside a logarithm. This 1/2 is not. So I can't simplify these anymore. So this will be my final answer. I'll do another video to show one more example of expanding, and then we'll try some examples of combining into a single logarithm.